day, grade 9s. How are you guys doing? Welcome to yet another physical science lesson. Today we are going to take a quick look at the kinetic particle theory of matter. So this is a topic that we did in grade 8. We touched on it. So this is basically or mostly going to be revision, right? So I'm just going to go through it as quickly as I can, but also try and explain some points that I think might be slightly difficult for some of you. Okay, so we know what matter is. We know that anything that has mass and occupies space is matter. We know that if we are sitting in the room that we are sitting in, we are looking at physical objects, solid objects that we can see, that we can touch. We also know that surrounding us in the invisible air, there are also particles that are microscopic, that are very small, right, which are there also in the air. So we are surrounded by matter, right? We are surrounded by matter. Some of it is in the solid state, some of it is in the liquid state, some of it is in the gaseous state. And why I am emphasizing this part of saying in the air surrounding us, because right now we all know that, I'm sure you now really understand when we say they are microscopic particles that are everywhere in the air. That's why you have this disease that is preventing you guys from coming back to school, because there is this unseen virus, right? It's invisible virus that's in the air, but it's there. But it's there. We're not going to say it's not there. It's there, right? But it's a case now of saying, even though it's microscopic, it's still there. Therefore, you have states of matter. Some of it is solid, some of it is liquid, some of it is gaseous. Some of it is gaseous. So even though you cannot see the things, the air that is surrounding you, it's there. It is definitely there. And those gaseous particles, such as the oxygen that you breathe in, they also occupy space and have matter, right? And they have mass. They also have mass. If you think of all the gaseous substances, such as oxygen, carbon dioxide, nitrogen, they also have mass, even though they are very, very light, right? But that's because you will see now under the principles of the kinetic particle theory of matter that all matter is made up of tiny, invisible particles. Tiny, invisible particles which cannot be seen with the naked eye. Okay? So I hope you guys have an idea of some of these principles of the theory of matter. If you don't, just pause the video for a minute, take a look at them before I explain them. Okay, so if we are looking at the kinetic particle theory of matter, we'll find that we have matter in different states: solid state, liquid state, gaseous state. And the state in which you find a substance determines the manner in which the particles in that substance behave. If something is in the solid state, it means that the particles are, yes, in constant motion, but effectively they are vibrating about a fixed position. I put in this table. This table is going to show you the different characteristics of each of the different states of matter: solid, liquid, and gas. But we must understand that when we talk about matter, we know that these particles, if you are thinking of something in the gaseous state, they are very small forces of attraction acting between the particles that are in the gaseous state, which is why the particles are able to move very fast. They move very fast and they move over long distances. Okay? They are not restricted to the same place as happens with something that is in the solid state. As what happens with something that is in the solid state. If you remember, I think we'll just talk about diffusion quickly. How we say if you spray a gas at one corner of the room, you will find that gas will spread throughout the room, because the gaseous particles are not fixed to the corner of the room, nor are they fixed to the position where they were sprayed. They are able to move throughout the room. However, if you were to drop your book, imagine that you are in your room, wherever it is you are, you drop your book on the ground. And then before you know it, you find that pieces of the book, one is now in a different room, one is now going that way, and this is just one book. No one has torn it apart. You know that something is happening there, right? So when something is in the solid state, it vibrates, the particles are in motion, but you can't actually get to see it. Another thing is that the particles collide against each other. So whether it's in the liquid state, or the gaseous state, or the solid state, when the particles are moving, right, when the particles are moving, they're going to collide, they're going to bump against each other. Imagine if you were in your classroom, right? Imagine if you were in your grade 9A or grade 9B classroom, and then we say everyone go into grade 9A, and we say run as fast as you can in that classroom. What's going to happen? What's going to happen is that you guys are going to bump into each other several times. That's what happens as well with particles of matter. Because even though all we are seeing is invisible air, there are actually millions of particles that are there in that air. So when they move, they collide against each other, right? So another thing, these are just different examples of objects with different states of matter. That's a brick. So the brick is obviously a solid, which has a fixed shape and a fixed volume, right? The orange juice that is coming out of the orange container is a liquid which flows easily, fixed volume, but its shape changes to match that of the container in which it is placed. Right. So this thing called a zeppelin is basically like an air balloon. It's like an air balloon. They used to use them long ago. They would fill them up with hydrogen, and they wanted to use them as a transportation device, right? As a mode of transportation. But unfortunately, the hydrogen gas was highly flammable, so when they used it, the Zeppelin blew up. It blew up, and they couldn't use it anymore, right? But basically, that's a big air balloon that is filled with gas. So gases now don't have a fixed volume or a fixed shape. It just spreads out to fill the container. So if you have a balloon and you blow into it, the gas particles are just going to fill up whichever container you put them in. Another thing we are going to look at, so what you can do is you can look at these three different states of matter and also look at these changes of state. Please pause the video for 2 minutes. Look at these different changes of state of matter before I explain them. Okay, so we have changes of state of matter where we have, let's see if I can zoom in just a bit. Right, water, solid, liquid, and gas. We know that we have three states of matter: the solid state, the liquid state, and the gaseous state. What we do is, or what we're going to do, or what we are actually doing is that we're going to use water to show how states of matter change from one state to a different state. So what you have initially is ice, right? What you have initially is ice, and that ice is at 0 degrees Celsius. So the ice remains in the ice or in the solid state. When you start adding heat to the ice begins to melt, right? The ice begins to melt. And observe here, this is going to come in the questions that you're going to be asked, at the end of this lesson as to why the temperature doesn't change. It only changes later on. So you start applying heat, and when your temperature, first it stays at 0 degrees Celsius, but the state of matter is actually changing. Then when you have it at 1 degree Celsius, 2 degrees Celsius, then the substance starts melting and changes into a liquid. When you apply more heat, the liquid water is going to start changing into water vapor, right? That's what, on the application of more heat, and vaporization starts taking place. When more heat is applied, now in this third stage, you will find that bubbles appear in the water, and this is known as boiling. This is now when the water is boiling. And the water, if it's pure water, it will only boil at a temperature of 100 degrees Celsius. And if it's pure water, it will also freeze at 0 degrees Celsius. So observe how you have different changes of state from freezing, melting, condensation. We look here, you have, this is molten iron, right? What we have on the screen right now. That's molten iron. And it says molten iron being poured out at an ironworks. Hot, over 1,540 degrees Celsius. Over 1,540 degrees Celsius. That's a ridiculously high temperature. That's a ridiculously high temperature. We also have, please pay attention also to this table. Let me bring it into focus. This one, where you have the melting points and boiling points of oxygen, ethanol, sodium, sulfur, iron, and diamond. You will find that the melting point of the nonmetals, such as oxygen, are very low. Oxygen's melting point is very low, negative 219 degrees Celsius. Then this is just a graph which shows changes of state. Please also pay attention to this graph, as it's going to influence the questions that you are going to be asked, right? These questions, please take note of these questions. Question 1 to 4. I want you guys to answer question 1, 2, 3, and 4 only, right? Let's do question 5 also. Let's do question 5 also. For those people who are serious, please do question number 5 also. This is the heating cave on which question 5 is based. So you just pause the video when you're answering the question, and then you can answer, right? So also on your PDF, on the notes, right, we put the different changes of state and a graphical representation to show you that when you're moving from the solid, going to the liquid, then going to the gas, and then back. Sublimation, freezing, condensation. All those states, you must know all those states and the substances which can undergo sublimation. Here they are. They are stated here. These are the substances which can undergo sublimation. So guys, please just read through the material. Like I said, it's simple stuff if you have read it. If you have not read it, for those who haven't even gotten to this part of the video, you will just struggle. But I hope that you were able to watch through the entire video, and I will talk to you in the lesson proper. Thank you for watching.